Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you welcome back to this study. Dear students, today in this second video lecture of week 15 for the course Applied Mathematics 1, we are going to learn about multivariable function. So in this video lecture, first of all, I would like to tell you about the multivariable function and about the partial differential equations and partial derivative and double integral. So first of all, definition of multivariable function. A multivariable function is a function with several variables function with more than one variable are needed in order to mathematically model complicated physical phenomena. Number one, like a rectangle has a width W and length L. The area of the rectangle is given by A is equal to W multiplied L. It is clear that if W and L vary, area depend on two variables, width W and length L. Area is said to be a function of two variables W and L. And number two, rectangular solid has width W, length L, and height h. The volume of the rectangular solid is given by V is equal to W into L into h. If W, L, and h vary, volume depends on three variables, width W, length L, and height h. So volume is said to be a function of three variables. So dear students, note that in a multivariable function, actually this is a function in which there are more than two variables. In the previous video lecture, we have discussed already a function with one dependent variable and other is independent variable. So in that function there are two variables, but now in this function, in this video lecture, we are going to discuss a function in which there are multi-variables. So a function with multi-variables called multivariable function. Now to express double integral, you see over here, in this double integral expression you see over here, integration from y is equal to y1 up to y2 and integration from x is equal to 1 up to x2. So this is the function of x and y. So integration with respect to s and integration with respect to y. Now this is the double integral. This is called a double integral, and provided the four limits of the integral are all constant, the order in which the integration are performed does not matter. If the limits on one of the rectangles involve the other variable, then the order in which the integrations are performed is crucial. Now for example, we have a problem to evaluate the double integral from integration from 0 to 3, integration from 0 to 1 of function x square into y with respect to y and with respect to x. So dear student, note that in this double integration, first of all, we take the integration of the function with respect to y. So integration of the function with respect to y, in this sense, now x square is the constant, so we just take the integration of y with respect to y. So integration of y with respect to y is y power 1 plus 1 divided by 1 plus 1, and now putting the limit from 1 to 2, because for this variable the integration limit is given from 1 to 2. So y square divided by 2 in integration limit from 1 to 2. Now putting upper limit is 2 and lower limit is 1. So putting y is equal to 2 and then putting y is equal to minus 1. Putting y is equal to 2 and then putting y is equal to 1. So upper limit, putting upper limit and evaluate the result, minus putting the lower limit and evaluate the result. Now we have, after simplification, integration from 0 to 3 by 2 and 2x square. Now the integration of this remaining function with respect to x. With respect to x implies that integration, you see over here, integration of x power n is given by x power n plus 1 divided by n plus 1, adding 1 with the power and adding 1 with the power in the denominator. So integration of x cube is now given as x power 2 plus 1 divided by 2 plus 1, and the limit from this expression is from 0 to 3. So putting upper limit x is equal to 3, so 3 power 3 27 minus lower limit is 0, so 27 minus 0, now 27 divided by 2. So this is the required result of the given double integral. Now double integral, to evaluate this double integral from 0 to 3 and from minus 2 to 0 of x square minus y minus 2xy with respect to y and with respect to x. So first of all, evaluate the integration with respect to y. Now integration with respect to y, so x square treated as a constant, and in this term 2x is constant. So integration of y with respect to y is y power 2 divided by 2, y power 1 plus 1 divided by 1 plus 1, and integration of this term y with respect to y power 1 plus 1 divided by 1 plus 1, and the integration limit is from minus 2 to 0. Now putting upper limit and then putting lower limit in this first term, and putting upper limit and then putting lower limit in this second term. So putting y is equal to 0 minus putting y is equal to minus 2, so minus 2 square mean 4, and 1 over 2 is the constant. Now in this term upper limit is 0 and lower limit is minus 2, so we have this 2 and 2 cancel, so minus x into 0 minus 4. Now to evaluate, integration from 0 to 3, minus 2 to the 4 minus 2x square and minus plus 4x. Now to take the integration, to evaluate the integration now with respect to x. So minus 2 is a constant, and integration of x square with respect to x and integration of x with respect to x. So integration of x square with respect to x, adding 1 with the power x power 2 plus 1 divided by 2 plus 1, and limit is from 0 to 3. Now plus 4 x power 1 plus 1 divided by 1 plus 1, and limit is from 0 to 3. Now putting upper limit and lower limit in this term, and then putting the upper limit and lower limit in this second term, we have minus 2 by 3 into 27 minus 0 plus 2 into 9 minus 0. And now minus 18 plus 18 is equal to 0. Now to evaluate the double integral from 0 to 2 pi and from 0 to pi of the function sine x plus cos y with respect to x and with respect to y. So dear students, note that first of all take the integration, like I want to highlight this point. If we obtain dx in this first position, then first of all integrate the function with respect to x, and if we obtain dy in this position, then first of all integrate the function with respect to y, and then at the second stage integration integrate the function, integrate the obtained result with respect to x. Now in this problem you see over here, first we obtain dx, so evaluate the integration of the function with respect to x, and then integrate the obtained result with respect to y. So like you see over here, to integrate the function with respect to x, so integration of sine x with respect to x and integration of cos y with respect to x. So integration of sine x with respect to x minus cos y, and integration of cos y with respect to x. Cos y is treated as a constant, so we obtain here 1, and the 1 integration with respect to x is x. Now putting the limit for cos x, x is equal to pi, and cos pi is equal to minus 1, and cos 0 is equal to again 1. So putting upper limit minus lower limit, and now putting upper limit pi, putting x is equal to pi and putting x is equal to 0, upper limit minus lower limit. So after simplification we obtain integration from 0 to 2 pi and minus 2 into minus plus 2 plus pi into cos y. Now to integrate this expression with respect to y, to evaluate the integration of this obtained result with respect to y. So with respect to y, this 2 is the constant, and we have integration of 1 is y. So for the limit 0 from 2 pi. Now integration of cos y with respect to y is sin y, and the limit is from 0 to 2 pi. Now putting upper limit and lower limit in this term, so 2 into 2 pi minus 0 plus pi into sin 2 pi minus sin 0, and sin 0 is equal to 0. Now sin 2 pi is also equal to 0, so 2 to the 4, so we obtain 4 pi is the required result. Now partial derivative. Dear students, actually in case of multivariable function, we use the double integration and partial derivative. In the previous video lectures, we have already discussed the total derivative and total integration. So in case of a simple function, we have already discussed derivative and integration. Now in case of multivariable function, in multivariable function, sometime we consider that x is a dependent, x is an independent variable, then y will be treated as a constant, and when y is independent, then x will be treated as a constant term. So in this case, when we consider one variable as a constant and other variable as a independent variable, in this sense we use the we consider the multivariable function. And in case of multivariable function, you see over here, to take the integration of this expression with respect to y, we consider x term as a constant, and when we take the integration with respect to x, we consider the y term as a constant. So in this case, now these are all the multivariable function. These function considered as a multivariable function. So in these multivariable function, now to take the partial derivative. In case of partial derivative, when we take the derivative of the function, y term will be treated as a constant, and when we take the derivative with respect to y, then x term treated as a constant. So suppose we have a function f of x and y which depends on two variables x and y, where x and y are independent of each other. So now in this case, this is the multivariable function. Then we say that the function f particularly depends on x and w. So dear students, note that for a multivariable function, this is not necessary that there will be more than two variables. This is actually independent sense, where x and y are independent of each other. When x independent, then y will be treated as a constant, and when y independent, then x treated will be as a constant. So x and y are independent of each other. Now then we say that the function f partially depend on x and y. Now if we calculate the derivative of the function f, then their derivative is known as the partial derivative of the function f. If we differentiate function f with respect to x, then take y as a constant, and if we differentiate f function with respect to y, then take x as a constant. So dear students, note that we have a function f of x and y which depend on two variables x and y, where x and y are independent of each other. Then we say that the function f partially depends on x and y. Now if we calculate the derivative of the function f, then the derivative is known as the partial derivative of the function f. For example, we have a function of x and y is equal to x square into y plus sin x plus cos y. Now to take the partial derivative of this function with respect to x, fx mean partial derivative of the function with respect to x. So now y will be treated as a constant. So the derivative of x square with respect to x is equal to 2x by using the power rule, and integration of sin x with respect to x is cos x, and integration of cos y with respect to x is 0, because now the y term is treated as a constant term. So we obtain the partial derivative of the function f with respect to x is equal to 2xy plus cos x. Now when we keep y as a constant, cos y become a constant, so its derivative becomes 0. Now similarly, to find the partial derivative of the function with respect to y, so the partial derivative of x square into y plus sin x plus cos y with respect to y is equal to x square, now treated as a constant, so the partial derivative of y with respect to y equal to 1, and the partial derivative of sin x with respect to y will be 0, and the partial derivative of cos y with respect to y, like you see over here, will be equal to minus sin y. So we obtained the partial derivative of the function with respect to y is equal to x square minus sin y. Now here a multivariable function of three variables x, y and z. To find the partial derivative of this function with respect to x, with respect to y and with respect to z. So first of all, this is the given function f of x, y and z is equal to x into cos z plus x square into y cube minus e power z. Now to find fx mean partial derivative of the function with respect to x. This is the representation notation of partial derivative of the function with respect to x. So with respect to x, cos z will be the constant, so this term will be as it is, and the derivative of x with respect to x will be 1, and y power 3 e power z will be constant, and the derivative of x square with respect to x by using power rule 2x. So you see over here partial derivative of the function f with respect to x is equal to cos z into 1 plus y cube e power z into 2x. And now the required result, the partial derivative of the function with respect to x is equal to cos z plus 2x into y cube e power z. Now to take the partial derivative of the given function with respect to y. This is our given function x into cos z plus x square into y cube into e power z. So with respect to y, this term is treated as a constant because there is no term of y. So this term derivative will be 0, and now with respect to y, x square and e power z treated as a constant, and these two constant terms are in the form of multiple, so these two terms will be as it is, and the derivative of y cube with respect to y by using power rule 3y square. So we have partial derivative of the function with respect to y is equal to 3x square into y square into e power z. Now the partial derivative of the given function with respect to x, with respect to z, of x into cos z plus x square into y cube into e power z. So with respect to z, x will be treated as a constant, and the derivative of cos z is equal to minus sin z. And similarly with respect to z, x square and y cube treated as a constant, and the derivative of e power z with respect to z will be as it is. This is the derivative of the exponential function. So the required result of the function with respect to z is equal to minus x into sin z plus x square into y cube e power z. Now we have a function w of variable x, y and z, which is given by x square into y minus 10y square into z cube plus 43x minus 7 into tangent and 4y. And the partial derivative of w with respect to x, the partial derivative of w with respect to y, and the partial derivative of w with respect to z are required. So first of all, take the partial derivative of the function with respect to x. So suppose this w function represented by f function, again you see over here, the partial derivative of the given function with respect to x. With respect to x, y will be treated as a constant, so the derivative of this first term is equal to will be 2x, and this whole term is a constant, so the derivative of this term with respect to x will be 0, and the derivative of this term with respect to x will be 43, and same derivative of this term also will be equal to 0 because there is no term of x. So you see over here, the derivative of the function with respect to x is equal to 2xy minus 0 plus 43 minus 0. So we obtained 2xy plus 43. Now the partial derivative of the given function with respect to y. So with respect to y, x square is a constant. So y derivative with respect to y is equal to 1, and 10z cube constant, and the derivative of y square with respect to y will be 2y, so 2 multiplied 10, 20, and the derivative of this term with respect to y will be 0, and the derivative of this term with respect to y, tangent 4y derivative, secant square 4y, and again derivative of the argument, again derivative of the theta with respect to y. So 4y derivative with respect to y is equal to 4, and 4 7 the 28. So the partial derivative of the function with respect to y is equal to x square minus 20 y z power 3 plus 28 into secant square 4y. Now the partial derivative of the function with respect to z is equal to derivative of x square into y with respect to z will be 0, and similarly derivative of 10y square z cube is equal to 10y square is a constant, and the derivative of z cube with respect to z 3z square, so 3 multiplied 10 30 into y square into z square, plus derivative of x with respect to z 0, and the derivative of tangent 4y with respect to z also equal to 0. So the partial derivative of the function with respect to z is equal to minus 30y square into z square. Now mixed partial derivative. For the mixed partial derivative, you see over here, if we take the derivative, partial derivative of the function x of the function with respect to x, and then again the derivative of this obtained result with respect to y, then this will be called mixed partial derivative. Like you see over here, partial derivative of the function with respect to x. First of all, take partial derivative of the function with respect to x. So with respect to x, the partial derivative is the derivative, this is the given function. If function is given x, function f and x and y is equal to 3x square into y square plus cos y. The derivative of this function with respect to x is equal to 3y square is a constant, and x square derivative with respect to x by using power rule 2x, and the derivative of cos y with respect to x is 0. So we obtain 2 3 the 6 into x into y square, the partial derivative of the function with respect to x. So now to take the again derivative with respect to y, to take again derivative of this obtained result with respect to y, this will be the mixed partial derivative, because two derivatives now are mixed. First of all, we take the derivative with respect to x, this is the obtained result, and now the differentiation with respect to y of this obtained result. So two variables are mixed, so that's why I called this is mixed partial derivative, and we denote the mixed partial derivative as the partial derivative of partial f by partial x with respect to y. So this symbol now can be written as partial multiplied partial square and partial y into partial x. So the obtained result is 6 into y square, and the partial derivative with respect to y of this obtained result is equal to 2y. So 2 6 the 12xy. Now to take the partial derivative of the given function with respect to y. With respect to y, 3x square is a constant, and y square derivative is 2y. So 2 3 the 6 into x square into y, and the partial derivative of cos y with respect to y is minus sin y. Now this is the obtained result of the partial derivative of the function with respect to y. So now if we take the partial derivative with respect to x of this obtained result, then two partial derivative will be mixed. So this is also called mixed partial derivative. So the partial derivative of partial f by partial y with respect to x is now equal to, this is the obtained result, 6y into x square, and x square derivative with respect to x 2x, so 2 6 the 12 into xy, and the partial derivative of sin y with respect to x is 0. So from 1 and 2 we know that the partial square f by partial y into partial x is equal to partial square f by partial x into partial y. So these two mixed partial derivative are equal. So dear students, the conclusion of this lecture, in this lecture we have discussed multivariable function, double integral of multivariable function, and partial derivative of multivariable function. In case of double integration, note that if we obtain dy in this position, then first of all evaluate the integration with respect to y, and then evaluate the obtained result with respect to x. So this is a very simple procedure for the double integration, and we can use this process also for triple integration. Now partial derivative. In case of partial derivative, if we differentiate function f with respect to x, then take y as a constant, and if we differentiate the function f with respect to y, then take x as a constant. Now this is the end of this segment. Thank you. Allah Hafiz.